Hello everyone, thank you for joining today. My name is Manu and today we're going to continue looking at the relationships for different properties of a gas. So we only have one learning objective today, and that's to understand the link between pressure and volume for a fixed mass of gas. So if you're ready, let's get right into it. Okay, so let's have a look at the link between pressure and volume for a fixed mass of a gas. So I have here two squares. The first square is designed to represent a larger volume, V1, and the second red square is designed to show a smaller volume, V2. Okay, so I think it goes without saying, but I have here in the corner to show you that volume 1 is greater than volume 2. Okay, so we're really talking about a large volume going to a smaller volume. Okay, so again, let's look at a fixed mass. So a fixed mass really just talks about a fixed number of particles. To keep it simple, let's just go back and look at our single particle. Okay, first let's look at V1. We know that pressure in a particle, pressure in a container, right, is really due to the force exerted by the particle on the walls of that container. Okay, so for the bigger volume V1, the particle will travel all of this way here. So let's just call that M1, right? And then it will travel all the way back to the other side. It will travel M2. Okay, so quite a large distance between collisions, okay? Because remember, every time the particle collides with the wall, only then is pressure actually exerted. So we can see here that the particle has quite a large distance to travel between its two collisions, because it can only collide with one or two of the walls, right? Let's just keep it simple. We're not looking up and down here. Now, so that's a pressure 1 for the for volume 1. Now let's have a look at what happens to the pressure when the volume starts to be decreased to V2. So let's look at green now. Now, the distance that the particle has to travel between collisions is so much shorter because it goes from there and it goes all the way back to the other wall. Now, distance between collisions is shorter for V2. So what does this mean? This means that in the same time, the particle in V2 exerts more force on the walls. Well, why is that? That's because simply it can do more collisions in the same amount of time because the particle is traveling a lower distance. If it's traveling a lower distance at the same speed, it's going to take less time for it to do, right? You can really see that if you follow the logic, right? So in the same time, the particle in V2 exerts more force on the walls. That means that pressure in V2, so the smaller volume, increases. So what sort of relationship does this show? Well, this really shows us that pressure and volume are inversely proportional. If volume decreases, pressure increases. So let's see that, right? So I have here a smaller volume, and then because we can see we're going from V1 to V2, and because it's inversely proportional, that tells us that pressure should increase. So that's really all there is to pressure and volume for a fixed mass of gas, right? The relationship between the two is inversely proportional. So now let's have a look at our worked example. So as always, we're going to highlight all of our keywords. So 50 centimeter cubed of gas, straight away, keyword there, at a pressure of 250 kilopascals is compressed into a volume of 25 centimeters cubed. Calculate its new pressure in kilopascals. Okay, so let's do this. So look at this. We're looking at gas and volume. What's the relationship between volume and pressure, right? So that's what we're looking at. So that's inversely proportional. So we can say pressure is proportional to 1 over volume. Okay, so we can see that our volume is decreasing. So volume is decreasing. So what should that mean? That should mean our pressure increases. And so the key to approaching questions like this is to work out what proportion my volume fell by, and then just multiplying that to our pressure, because remember, one falls and the other rises. So to rise we must multiply, and to decrease we must divide. So let's have a look at the proportion our volume fell by, right? So we go 50, the initial, over the final 25, and that equals 2 times. So our volume was decreased by 2. So what should our pressure be increased by? Well, that's just 2. So we just do 250 kilopascals multiplied by 2, and that equals 500 kPa. Now, you might be wondering, oh man, why didn't you change 25 centimeters cubed into meters cubed, and why didn't you change kilopascals into pascals? I thought those were the standard units. Well, those are, but number one, our question asks for it in kilopascals, so we just keep in the same one. And also, if your left-hand side of the equation has the same units as the right-hand side of the equation, the units sort of cancel out, and you can use whatever you want. It's just the only real time you have to convert is when you have two different sets of units, or when your answer asks for a specific set of units. So now you understand how to do calculations to do with volume of a gas and pressure of a gas.